Today we're going to take a look at the algebra of functions. So what I need you to do is take a minute, pause the video, and write down all 6 of these functions. We're going to use them for every example. Okay? So take a minute, pause the video, and write down these 6 functions. Now that you have the 6 functions written down, what we're going to go through and do is find a value or a new expression for each problem. If there's a number inside the function notation that I gave you for the problem, your answer will be a number. If there's a variable inside, then you're going to have variables left in your answer and you're going to have an expression, not just a number. The first 3 problems that you see at the bottom of your screen are problems that we have done before. So, k of -3. If I look at the k of x function, I need to replace each x in -x plus x squared with the -3 that's in the parentheses. So this is going to be equal to negative of -3 plus -3 squared. Well, that'll be positive 3 plus 9. That comes out to 12. So the answer for problem number 1 is 12. Problem number 2 is j of 8. So I need to look at the j of x function. So this is going to be the same as replacing the x in j of x with an 8. 8 to the 1/3. Well, that means I have the cube root of 8, which is 2. For our third example, we need to look at f of x. 3x minus 1. I'm going to replace the x with a -4x. So this is going to be 3 times -4x, then minus 1. Since what's in the parentheses here is not just a number, my answer will not be just a number. It is most likely going to be an expression with a variable in it. And in this case, we're going to end up with -12x minus 1. Okay, so that should be a little bit of review for you guys. Let's take a look at something that's a little bit new. Here are 3 definitions for operations with functions. The first one says, in parentheses, f plus g of x. Well, what does that mean? That means find f of x plus g of x. If there was a number where the x was, that would, for example, 3, that would mean find f of 3 plus g of 3. Find the 2 numbers separate and then add them together. The second one, f minus g of x, is going to look almost exactly the same. It's going to be f of x minus g of x. And the last one, fg of x, well, that's f times g. So that's f of x times g of x. Let's take a look at a couple of examples. Problem number 4. Remember, we're using the same 6 functions that I gave you at the beginning. We want f plus h of 2. Well, the first thing I recommend writing down is, well, that means find f of 2 plus h of 2. And now you have 2 different numbers to find, and then you want to add them together. F of x was 3x minus 1, so f of 2 is 3 times 2 minus 1. There's f of 2. Now I need to find h of 2. H of x was 3 over x plus 1, so I'm going to write in 2 plus 1. And now I just need to simplify to a single numerical value. So this is 6 minus 1 plus 3 over 3, which is, in fact, 1. So now I really just have 6 minus 1 plus 1, which is plain old 6. So in this case, f plus h of 2 is 6. take a look at number 5. hg of 7. Well, for starters, that's a product. So I need to figure out what is h of 7 times g of 7. H of x was 3 over x plus 1. So now I'm going to have 3 over 7 plus 1. And I'm going to multiply that by g of 7. G of x was x squared minus 1. So we're going to put that in parentheses. X squared will be 7 squared, then minus 1. Alright, let's simplify. Let's start with the fraction. 3 over 7 plus 1 is the same as 3 over 8. We want to multiply that by 7 squared is 49. 49 minus 1 is 48. If it helps, make it 48 over 1. Since it's a fraction times a fraction of sorts, we can cross-reduce. I can divide by 8 and get 1, divide by 8 and get 6, to get a final answer here of 3 times 6 is 18 over 1, or just 18. Alright, let's take a look at some more. Problem number 6 has a couple of things going on. We're going to start with what's inside the brackets, the k minus g of 0. So for starters, I'm going to leave the 3 exactly where it is. I'm going to deal with the inside first and work my way out. So this is k of 0 minus g of 0. And I'm going to multiply the whole thing by 3 at the very end. If you want at this point, you can distribute the 3, but it's not really going to save you any time, so I recommend just leaving it out in front and dealing with it at the very end. Alright, k of x was negative x plus x squared. Well, negative x, in this case, will be 0, plus 0 squared is still 0. K of 0 is, in fact, 0. Now I need to find g of 0. G of x was x squared minus 1. Well, that'll be x squared, 0, minus 1. So here I have 3 times 0 minus negative 1. That double negative in the middle is really a positive. So this is 3 times 1 for a final answer of 3. Problem number 7, negative 4m to the 16th. This one's actually a little bit easier than the problem we just did because there's only one function involved, m of x. M of x was x to the 1/4. So this is going to be just negative 4 times x, 16, to the 1/4. Keep in mind, exponents have to come before multiplication. If I write that with a radical, what's the index? The 1 or the 4? If you said the 4, you're right. This is the 4th root of 16. The 4th root of 16 is 2. That's because 2 times 2 times 2 times 2 gives you 16. So our final answer here is negative 8. Alright guys, we got 4 more problems left. Problem number 8 has f plus g of x. So, since there is an x left, we're going to have a function for an answer instead of having a number for an answer. So we'll have variables left in our answer. We'll still have x's left over. F of x was 3x minus 1. And g of x was x squared minus 1. When you put the functions in their place, I recommend that you put them in parentheses, especially when it's something other than addition, because you have to be very careful to make sure you distribute things like negative signs or you multiply properly. So the parentheses will become very important in later examples. But here there's nothing really to distribute, so if I wanted to write this in standard form, look for the term with the biggest exponent, that would be the x squared. And I'm going to have plus 3x. Negative 1 plus negative 1 is minus 2. Okay. Now for number 9, j of x times j of x. Times j of x. So you can use the same function more than once in a problem. That's okay. J of x was x to the 1/3. Now who remembers what you're supposed to do when you are multiplying bases? Do I add the exponents, multiply the exponents, or subtract the exponents? We are going to add these exponents together. 1/3 plus 1/3 is going to give me x to the 2/3. Now remember, you cannot leave fractional exponents in your final answer, so what you need to do is convert this into a radical. Is the index going to be the 2 or the 3? If you said the index is 3, you're correct. The index is always the denominator in the fractional exponent. That means I have x squared on the inside. So there's my answer for j times j of x. 2 problems left. G minus k of x. So for starters, this is g of x minus k of x. The order is very important because it's subtraction. G of x was x squared minus 1. Minus k of x was negative x plus x squared. So here you have to be careful and you need to distribute the negative sign. So I have x squared minus 1 plus x minus x squared. And I'm going to end up with x minus 1. The x squareds are going to cross each other off. I'll be left with negative 1 plus x, or x minus 1. And now for our 11th and final problem, Jm of x. That's going to be j of x times m of x. J of x is x to the 1/3. M of x is x to the 1/4. Now, if you follow the problem that we did for number 9, where we did j times j of x, we added the exponents together. I want to add these exponents as well. But in order to add these two numbers, I need a common denominator. So, this is going to have a common denominator of 12. 1/3 is 4/12. And then 1/4 is 3/12. If I now add those two exponents together, I'm going to get x to the 7/12. Again, you need to convert your answer to a radical. The index is the denominator, so that's the 12. And I have x to the 7th. I hope that you found these examples to be helpful in figuring out how to do the different types of algebra involved with functions. Please keep in mind that if there's a number in the parentheses, your answer should come out to a number. And if there's a variable left in the parentheses, your answer should come out to a variable.